Welcome back, my fellow arcade and electronics enthusiasts. Sean back here with you with another repair video. This is going to be a early vector beam, if you will, early CinemaTronics Space Wars C CPU PCB. And yeah, just getting ready to start looking at this one. And the first thing I noticed right off the bat with this board is it does not have the status LED in the corner, right? The status LED that goes right here, it does not have that. And this is an early version of this board, obviously, before they put that in there. And what I'm going to do is I'm going to populate this, and off of the schematic I'm going to put that status LED on this board. The reason I want to is because it's not really a reset indicator as much as it is a status LED. It lets you know that the status of the processing portion of this board. If the LED is out, that means the processing part, the processing functionality of this board is working. That does not mean that good signals are getting sent to the monitor. It just means the processing logic part of this, all of the math, all of the memory, the math, all of that, the processing, everything a CPU does, that portion is working. So it's not enough just to probe the reset pin, because the reset can be out, but the thing ain't really working. I've seen that 1,000 times on boards where it's not doing anything and you probe reset and reset is not resetting, yet it ain't working. So that's a very good indicator to have on the board. It lets you immediately know the status of this thing. You turn it on, if it flashes and goes out, that means this thing is processing. Then if you have issues after that, it's just the output circuitry to the monitor. It's more pinpointed. It's easier to deal with. So I have the schematic here. This is the part of that schematic. And it says reset indicator circuitry, but like I said, it's really more status indicator circuitry, really. It latches this proceed signal with the reset signal is what it does. But this board is not set like this. This was a change. They changed this board later on. And this says revision B. So yeah, this is before they made the big change on that and put that LED in there. So what I'm going to have to do is manually cut any traces that they have on here and retrace this thing to match this schematic. So that's what I'm going to do. And I'm going to have that to where I can easily tell the status of this board. First and foremost, that's what I want to do. Okay, and this is what it looks like on the top side of the board. There's your LED, and a 00 goes in here. It's this chip right here, 00. And you can see I have one of the traces, that's pins 8 and 12 connected. And that's just conformal coding to hold that in place. And then there's another one underneath there you can't see, connecting pins 3 and 6. Yeah, 3 and 6. Those are the two top sides, 3 and 6 and 8 and 12. And then on the back side, most of the trace work is done on the back side. And a couple of the traces that I cut I didn't need to, so I repaired. And there's the 100 ohm resistor to 5 volts on the anode of that LED, and the cathode goes to pin 3. Yeah, this is the cathode going to pin 1, 2, and 3. And you can see pins 1 and 2 are jumped together. Pins 4 and 5 are together, and these traces are cut here. But this one I had cut initially, but I fixed it because 1 and 2 is tied to 3 and 4, or 4 and 5. 1 and 2 is tied to 4 and 5 right here. 1 and 2 and 4 and 5 are tied together. So I just repaired that trace that I broke. And yeah. This was originally this was jumped from here over to pin, this third pin, which goes down to here. Well, I cut the trace right here to to isolate this off of that, and then I just jumped this down to there and then cut that trace so that that doesn't loop back around down there. And yeah, this is the reset line, which I had to tap from right here where the reset comes off of this, and you send that over to here. The proceed line is already right here, which I had cut that, and I realized I needed that trace, so I had to repair it. So that you got the proceed line and the reset line coming in, and it's just a latch circuit, and you got your LED there. So that's it for that circuit. Yeah. Now we have our status LED. Okay, and yes, I had already verified that this board did not work. I hooked it up to a CinemaTronics monitor that I know works, and I didn't get anything. So I know this board doesn't work, and if I turn it on, you'll see the LED stays lit. That means it does not work. So the CPU part of this board does not work. Yeah, so I like having that status light. That's way better than not having it. So okay. Okay, so I replaced a broken transistor. That one right there was broken off, so I replaced that. It's just a 3904. And one thing I always do on these boards right off the get-go is I remove the RAMs and test them in the Inquisitor. One of them was bad. This is just an easy, good place to start when troubleshooting these boards, is start with these RAM, remove them, test them, make sure they're good. One of them was actually bad, so I replaced one of them. And after doing that, socketing them and replacing that cap, check it out. See that? Our status LED tells us this thing is working. Turn it off, turn it back on. It should flash really quick and then go out. That's it. She working. So I'm going to hook this up to a chassis and see if it makes deflection. Okay, so I have this board hooked up. This is a CinemaTronics deflection board that I know this one works. I got it hooked up with the deflection transistors and everything, and I got a yoke plugged into it. This is just an extra yoke I have here. And when this comes on, you should hear this thing chattering. if it's working. If the board's really working, you'll hear this thing giving off a chatter. So we'll go ahead and turn this thing on. Make sure our light flashes. And I do hear deflection. You hear that? Nice. So I will go ahead and hook this thing up, put an actual monitor together, and we'll see what it looks like. All right. The picture's really dim because it's, I think the high voltage unit in this thing needs to be recapped. I heard a massive snap back there, and it's just not very bright. But deflection wise, it looks good. It's working fine. There's your ship. There's a little there's the center star thing. A bunch of little twinkling stars around. Really cool. Looks like the Starship Enterprise right there. So it looks like it's the Starship Enterprise versus asteroids. The asteroids ship versus the Starship Enterprise. That's it. This baby's fixed. And we put a nice, we got our status light on there. So if this thing ever fails, you'll know what's going on. Yeah, I heard a really massive snap. I think a cap might have popped in this high voltage cage. Not exactly sure, but it's not as bright as it should be. Yeah, it's okay. For the purpose of testing out this board, it works fine. Oh, no. Cool. Excellent. And I do have the soundboard for this thing right here. So maybe we can test out some sounds. Okay, I have the soundboard hooked up. And I had this, get that out of here. But from the schematic, from what I could read anyway, I wrote down some of the controls, and I had this plugged in there with just kind of, frayed ends. This last pin 26, this last one, this black one coming off the end, that's ground. And then all of the other ones are just input signals. And I've been just kind of touching around, and I've been doing firing and moving and all that good stuff, but I've not found any. There's no sound. This thing makes no sound. I can hear the sound coming through the speaker, so I know the amps are good and everything. But there's no sound. And I had noticed this, and I marked it with a red dot, because that thing has it's either an input or an output pin. I think it's an output pin that was shorted to ground. So that, I do not believe this chip is any good. This 7406. So I'll take another look at that. But yeah, that thing doesn't this thing doesn't have no sounds at all. So yeah. It doesn't kill the board. I mean, it still works, but I'm going to continue messing around with this. I have not seen thrust yet, so I don't think I've gotten there. But we're going to end up having to troubleshoot this board. I think it's this chip, because it's got an output that's shorted to ground, and I'll show you that. But I'm just going to keep messing around. I'll be back. Okie doke, this is that soundboard. And I did go through with all of the controls, and I found all of the controls. So that works good. That all works good. I'll show you here. This chip, I'm going to put this on diode mode to start. Okay. Let's see if I can. I don't know. This thing just. I don't know. Let's try this. How's that? No? How about that? I guess. Okay. We'll try that. And I have it on, oops, did it move? Diode mode. And I will put the red lead to ground, which is the tab of the 7815. And if I go to, that's the, okay, ground is 0. 5 volts is good. And I just go down these inputs. That's an input and output. Input, out, in, out, in, out, in, out, input. That is an input, which is grounded. So, and this input goes to this. It just comes over to here to nothing. It doesn't go anywhere else. So this input is internally shorted. That's what's going on with this thing. Yeah, because if you follow that input pin, it comes down through this wire here and then goes over to this and then out to the main board. So this input, I'm going to remove this chip as it looks like the input is internally grounded. So I'll get that out and we'll take a look at it. I also removed this. This thing had two 100 microfarad 160 volt Nichicon caps. I'm going to put the more proper, just basic 50 volt cap in there. I'm sure it's probably just a 50 volt cap. And I'll go ahead and keep these. These are nice caps. Nichicon 160 volt. So yeah. Yeah, I got that 06 out of the board, and this thing says not found. Let's see. But man, I don't know how much I trust this thing, but it's usually pretty good with these simple chips like this. But yeah, this chip is no good. So yeah, I'll socket that and put a new one in there. Yeah, and I have this chip here, and if we go ahead, I've got this on continuity, and I can go from ground to pin 9, the input, and it is just shorted straight to ground. we'll get that guy replaced and see what we get. Alright, now I've got this thing hooked up. I should be hearing sounds, and I'm getting nothing. And I went to check my voltages on here, and you'll see here, ground is the tab of this guy. This is the positive regulator. Input is 25 volts, and then common, and output is, there is no output. There's no output on this guy. The negative 15 regulator, you got common, input, negative 25, and the output is negative 14.75. That's fine. This one's dead. This positive regulator's dead. No voltage on the output pin. So we got to remedy that. That's got to be replaced. Yeah, a lot of times these regulators are just knockoffs. If you buy cheap ones like SK or ST or whatever, I buy Texas Instruments parts from like Mauser or DigiKey. As much as I can. So I'm going to go ahead and stop and replace that guy. See what we get. Okay, we are hooked back up, and I did already check the voltages. There's my new regulator in the board. I already checked it. It's good. 15 volts on the output. So let's go ahead and fire this up. Okay, it definitely popped. I'm going to have to coin around and see if I get anything. Okay. I have everything hooked up. I'm just going to kind of mess around and see what we get. Putting in time, putting in quarters. I put in 10. So now we will start. I'll just pick any of these, I guess. Let's do keyboard press 4, which is wire 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The orange wire here. Alright, so now we're in that. I like on the little keyboard that's on the control panel, 0 through 9 keys, I pressed key 4. So whatever that is. Okay, let's do some sound stuff. Fire. If you hear, very low volume. Apparently, that number 4 keyboard push was the bullets wrap around. And someone just blew up. Let's move forward, I guess. Yeah. Very low volume. It's there. All the sounds are there, but the volume's really low. And it doesn't... volume pot doesn't. Hear that? Man, I remember playing Space War for the Atari 2600, and it was a lot like this. Yeah, so we have a we have to look at see why in the world we have no volume basically. So yeah. All the sounds are there. It's just a volume issue. So I'm curious. So we'll figure it out. I'm going to turn it off. And I'm going to go ahead and remove this board and take a look at and see what's going on. Just kind of look at it. I got the little schematic for that board printed off here, so I'm just going to go over it and look over it. See if there's any there. It looks like this whole thing was rebuilt at some point. And those are the two caps that I replaced. But yeah, it looks like this thing has been rebuilt at some point. So I just want to go over it and make sure all the right parts are in it. Okay, after looking at this thing for a bit, this pot says 50K. And then a 470 ohm going to ground. See that? 50K. And then 470 going to ground. So, where is our 470 going to ground? Just curious. And there's the pot right there. Or is it? Yeah, that's the pot. So it's either... Is it one of these? I cannot tell. I cannot tell. I'd have to put the camera down. I'm going to do that. I'm going to put the camera down and I'm going to find this circuit. Okay, I found this resistor, but it's not a 470 ohm resistor. It is this guy right here. It's that guy. And that is a 750 ohm. Purple, green, brown. 750. That comes off of that pot right here on this leg. It comes over, and that's the 750 ohm resistor. Let me grab something to point with. So sorry, so sorry. Okay, there is that pot. Here's the 750 ohm resistor, and this is ground. This middle terminal is the common for that 75 or 7815 regulator. So that's that. Now, curious enough, this pot, see down there, 10K, right? 10K. 50K. So what would happen if you have a 10K pot in that spot instead of a 50K pot? That is the minus input to this amp. This is the final out amp. And how amps work is it will amplify the output in trying to equalize its inputs, basically. So the more of a difference this line has on it than the top line, the higher the amplification. So the least resistance, the less change there will be here. The less of a voltage drop there's going to be. The bigger voltage drop there is right here on this little circuitry, the bigger voltage disparity difference, the bigger voltage difference is going to be at these two inputs. So this is going to amplify more. So we need to put the proper 50K pot in this spot so that this thing can amplify. That seems to be what the problem is. All right, well, I got this guy out, and I want to I want to show you what they did to put this pot in here. They drilled new holes and opened up that hole. You see that? That is some serious half-assery right there. All right, let's go ahead and put the proper potentiometer in there and see what happens. We're hooked back up. I'll go ahead and put the here's the old pot. Hear that? Whoa. Curving bullets. It's nice and loud. Trying to get some movement going here. Hear the thrust. 23. Yeah, there we go. Thrust and turn. Nice. Uh-oh. Sound just went out. Interesting. We just lost one of our voltages. Did you hear that snap? Yeah, the sound, this soundboard just blew up. Obviously the monitor's still good with its voltage. It's just it blew up on this. Let's see what blew up. Okay. Put this on ground. Common. In. Out. We got negative voltage. In. Out. We got voltage here. Okay, our voltages are good. Something clearly blew up. Still sounds like our amps are working. I'm still hearing amplification. Yeah, no sound. I'm going to turn it off and try turning it back on. I don't see anything that obviously blew up. I definitely heard something. Nope, the sound's back. Whoa, that's loud. Now it's okay. What in the world happened? You know what? That's the same snappy pop that I heard with the monitor. So I'm wondering if this chassis is actually, or this. I had this thing grounded. Yeah, it's working again. Now, I didn't have a 50K pot, so I put a 100K pot in it, so it's really super sensitive, and it gets really super loud. Yeah. All right. Yeah, I don't know what that was. I don't know. That was a weird snappy. I think it's got something to do with this monitor, though, because this thing has been snapping like that. Yeah, I think there's something up with this high voltage box. But it's working good. That was just a weird anomaly. I don't know. Turned it off, turned it back on, and it's working. It's just something to do with that monitor, I believe. So I may turn this off. And you know what I'm going to do? This is what I'm going to do. For this burn-in test, I'm going to play this blind. So I'm going to turn this off. And I'm actually going to just unplug this and unhook this and turn it on. Yeah. And we should be playing blind now, I would think. Put this up. I should be able to coin it up and then start. Yep. It's playing blind. There you go. This is how I'm going to burn test this. Blind. And then I'll make sure I'll turn it back on. Yeah. Yep. That's how I'm going to do it. I'm just going to let it run just like this for about 3 hours, this board. And I'll come back out, turn it off, plug the monitor back in, make sure everything's good to go. So I think this thing's funky. It's that high voltage box, I believe. It's funky. So cool. All right. Well, I guess that's going to do it for this one. We put the status LED in this thing, remember. This thing had a bad RAM in it, and that was what was wrong with it. We replaced the bad RAM, put the status LED in. This guy, I replaced those two caps, had a dead regulator. It had a bad 7406, and it had the wrong pot size, the wrong value pot. And that's it, I believe. Yeah, and this thing was missing a transistor as well. I replaced. That's it. So I will see you guys on the next Classic Arcade Repair. And bye for now.